combustion, that is the exothermic release of heat due to the chemical reaction of fuel and an oxidizing agent. So that will be normally oxygen, no, and air. So we have called this two types of combustions. So that is the internal and external combustion. So for internal combustion, so that is the combustions that takes place inside the combustion chamber. Example natin yan is spark ignition engine. Okay, so we have that one. Then we have the compression ignition engine. So isang example din yan. Then we have the combustion ignited by the gas turbo engine. Now for external, so we have your working fluid, so that is contained internally. So it is heated by the combustion in an external source through the engine wall or a heat exchanger. Now we have here, I have bring down here the sample heat exchanger natin. So taking closer look, okay. So ito yung tsura ng heat exchanger. So I hopefully sana na-discuss ito sa inyo during your heat transfer. Usually this is discussed in the heat transfer, yung heat exchanger. So hopefully na-tackle yan. Then we have for the sample of your internal combustion engine. So lahat naman are very aware of that, kung ano yung tsura ng internal combustion engine, since ito na rin yung naturo sa Thermo 1 ninyo. Okay, so it is already being discussed na rin sa thermodynamics, and also gas turbine. So this is a form of internal combustion, so which is yung takes place nung combustion are inside, no? Okay, so that are the samples ng types of combustions that we have, no, for internal and external. Okay, now for the combustion process, so we have we require yung fuel. So that is the one of the requirement in order to have a combustion. Then we also require the air, no, to continuously. Okay. Then we have your furnace. So air, fuel, furnace. Then we have your turbulence of air, so that is be providing pressurization. Then also we have your time that required to produce a combustion. So usually sa naman, in order to produce of fire, so usually we have the triangle of fire naman usually, and we have your air, fuel, and also the source. So mawala lang yung tatlo doon, yung fuel, air, and source of fire, combustions. So there will be no combustion that will take place. Now this is for the combustion process sa continuously. So we have therefore engineering applications, no? Now for our combustion formula, we have your fuel, okay, and we have your oxidizer. So the product will become your products of your combustion. Then you have your heat plus your heat that is being produced during the combustion. Now we have your fuel. So we have three types. So you have your solid, liquid, and you have your gas. Now for our solid, so we sample our coal, dendrothermal, and we have your biomass. Then for liquid, we have your hydrocarbons, so that is derivatives of from the alcohol. So yung mapapansin nyo, Mostly our chemical formula of our fuel are in this form, CXHY. Okay. Now for gas, we have your natural gas, hydrocarbon derivatives. Okay. Then we have your methanol, ethanol. We have also the biogas and also the LPG. Now for computing the air-fuel ratio, so we have these equations now. So that will be the air-fuel ratio. Our air-fuel ratio, that will be the ratio of mass of air divided by the mass of fuel. So this is the actual air-fuel ratio. Then it is equal to the stoichiometric air-fuel ratio. So it is represented by air, A, F, then we have your S. So that means that is an stoichiometric calculation. Then we're going to multiply that one by 1 plus your excess air. So that will be yung actual. So stoichiometric, that will be your ideal. So if you're going to plus it by 1 excess air, so that will be the actual air-fuel ratio. Now for the in order to complete the combustion, okay, so the complete of the combustions of fuel, so that means that all of its combustion components are gasified. So all of the carbon, so what is whatever that may exist in fuel is completely burned out. So kung ano yung pinasok mo will be converted into another product. So for example, that is we're going to combine carbon and your oxygen. So if you're going to do a combustion, that one, so the product will be a CO2. Okay, so it means that all carbon came out and we have the product of carbon dioxide. So what I have here is the fuel. I'm going to add it with air. So we have the products of combustion, then we have your heat. So we have two types of heat. Okay, we have your higher heating value and lower heating value. Now for higher heating value, defined as heating value where the product of the combustion is in liquid form. Now for lower heating value, water in product are on the combustion is in vapor form. So you will notice there is a product of H2 water in the product of combustion. So that is mapapansin nyo minsan sa mga sasakyan. So mostly kasi napapansin ko is yung mga gasoline engine. So mapapansin nyo dyan sa combustion nila, there is an lumalabas na droplets of fuel. Mapapansin nyo, if you will be following, susundan nyo yung nagko-cruise na gasoline car, so mapapansin nyo, there is a droplets of water that is coming out from the combustion chamber, because our product of combustion, there is a product of H2O. So later on, we will do a stoichiometric analysis or calculation. So we will be observing that there is a product of H2O in the product of combustion. Now, I have here the boundary of closed control volume or system. So for kung saan takes place yung combustion. Now we're going to supply the mass of air, okay, then the mass of fuel, then finally, yung mg, which is the mass of the flue gas. Okay? Now, for our mass balance, so if you're remembering doon sa tinuro previously from your call this sa natin, sa thermodynamics. So, going back, thermo 1, so you have your mass balance, no? So, our mass balance dito, so that will be ano yung pumapasok, then ano rin yung lumalabas. So we have your mass in, no? So mass in, that will be equal to the mass out. Okay. Then we have your mass of air. So usually we pumasok, we have your mass of air. Okay. Then we're going to add isa pang pumasok, which is your mass of fuel. Then this is equal to the mass of flue gas, which is the product of combustions natin. Okay, so okay. Then for our flue gas mass flow rate, okay, so we can compute that one by your mass flue gas mass flow rate. So from your mass of air plus your mass of fuel, so that will be the mass of your flue gas, so that will be mg. So we can rewrite our equation. So your mass of flue gas, so that will be equal to the mass of fuel, no? Then going to multiply it by the ratio of mass of air, then the mass of fuel, then plus 1. Okay, so this is in the units of kilogram per second. Okay, so that is a mass flow rate. So you will notice if you're going to distribute, so this is form of ano lang na representing the equation in terms of mass of air and mass of fuel, the ratio of mass of air and mass of fuel. So this is the same value that we have here dito. So bakit natin ginawa ganito? In order to achieve an air fuel ratio, so we try to rewrite the equation to express it in the mass air fuel ratio. No, so this is already equal to the air fuel ratio natin, if you can still remember, no? So kanina, okay? So that will be the mass of flue gas na. So that will be equal now to the mass of fuel. Then it will be multiply the air fuel ratio. Okay. So air fuel ratio then plus 1. Okay. So we have now mass kilogram per second. So we can get now what will be the mass of flue gas that is coming out after the combustion if we have the mass of fuel and also the mass of air that is introduced doon sa combustion chamber or the combustion area. Now for the incomplete combustion naman, so it defined as fuel represents of loss of heat since they should have been given off of additional power. So use had the fuel been completely burned. So we have indicators of complete combustions. We have the product of CO. Okay, so that one. So we have also the product which you have your H2, so, and soot of exhaust gas as well as unburned combustible in refuse. So ideally, in actual, so if we have the combustion chamber, so there is what na tinatawag na nagkakaroon pa rin ng incomplete combustion. So one of the causes is that is yung sometimes the air fuel ratio are not properly attained, so kaya nagkakaroon ng ganun. But anyways, nagkakaroon pa rin talaga siya ng incomplete combustion. So that's why nagkakaroon tayo ng mga soot. So when we say soot, so example of that one is yung mga mapapansin niyo when you open the combustion chamber ng internal combustion. So meron siyang mga langis-langis, okay? So oily products or carbon product. Okay? So sample nito, I have here yung binuksan na images ng ng internal combustion engine. Okay, so mapapansin nyo dyan, we have this carbon deposit. Okay, so yung carbon deposit na yan, okay, so we have that carbon deposit doon sa gilid niya. So this is a form of one of the product of incomplete combustion, yung build up ng carbon na yan, and also yung build up ng carbon na yan dito sa gilid. So that is a carbon deposit from the incomplete of combustions. So and it provides loss sa efficiency ng engine because this one provides also a friction do sa mga moving parts. So once na nagkaroon deposit niyan, so that provides a wear deposit. So nagkakaroon ng wear doon sa moving parts, and also that also increases yung friction, no? And also pag marami ng ganito, so also it takes place inside the combustion engine. So yung volume of air that is pumapasok doon also is being minimized. So So because yung deposit also taking place the volume of the cylinder. And also this one, you will notice this one, no? Okay, so this also a product of deposit pa rin, di ba? Okay. So, yan yung product ng carbon na deposit, okay? So, mostly this is in the exhaust, no? So, kung yung engine mo, if you have your engine here, okay? So, you have your piston and your exhaust pipe and your intake pipe dito, papasok doon intake. Then, lumaki yung product of deposit ng carbon deposit dito sa exhaust mo. Eventually talaga yung taking place nung ano to, it provides a friction doon sa or pressure loss pag discharge mo yung product of combustion. So that is also means of loss on power and efficiency of the engine. So okay, so that is one of the burn disadvantage nung ano. Nowadays engines are made kinakabitan na siya ng tinatawag na okay, so nowadays yung ano yung system ng mga makina ngayon, they have yung tinatawag na recirculated o yung return exhaust. So if this is our exhaust pipe, so if this is your exhaust pipe, no? So there is called it a motorized valve dito. Then there is a pipe bypass pipe papunta doon sa intake. So the main purpose of this one is to ensure that yung percent ng incomplete combustion will be subject to enter again doon sa combustion chamber para ma-burn talaga siya ng completely burn, masunog talaga siya ng gusto yung yung fuel and another mixtures of air para magkaroon ka ng complete combustions. So, ang effect nun is to lessen the environmental impact doon sa environment. So because of incomplete combustion, so that is very toxic also, incomplete combustion. So it contributes to the ozone depletion and also pollution to the environment. So that's why mga modern cars nowadays, so they have a return exhaust pipe or exhaust gas to provide in the combustion. So later on we'll be dealing yung ano, we will be computing so later on how much will be. So if this type of return exhaust gas increase the efficiency or decrease the efficiency of the system, but I predict it. So later on when we find out during the stoichiometric analysis, so we will be able to determine so what is the impact of that one. So usually ang binabalikan natin dito, this is already product of combustion, so mostly there's carbon dioxide, CO2, no? So it's a mixture of H2O also, meron din yan. So in other gases, so binabalik natin ulit siya sa combustion yan. So we will be going to find out if that affects the meron ba siyang bigger impact. So meron ba siyang increase in efficiency or decrease in efficiency to the engine. So okay. Now next we have the methods of reporting the analysis. So one, we have the gravimetric analysis, gravimetric or ultimate analysis. Now, so this is based on the percent by mass of X. Okay, so then so that is mass of X that will be divided by the mass of your total mass. So that is by percent analysis. So that is called the gravimetric or what they call the ultimate analysis. Then next we have another method of using for the reporting the analysis. We have the volumetric, no? Volumetric analysis. So that is by percents of volume. So percent of volume from a given value of X, then divided by the total volume, or by means of number of moles of X divided by the total moles of values of the product to be analyzed. So that is by means of volumetric analysis. Now, in combustion, we only considered is your dry air. So we have your nitrogen and oxygen, so and other traces of inert gases that will be used in the combustion. Now, for dry air, mostly we'll be dealing only yung nitrogen and oxygen. So by mass of air, for example, we have 1 kilogram of air. So there is a 0.23 kilogram of oxygen there. Then we have 0.72 kilogram of nitrogen. Then 1 volume of air, so that is 1 cubic meter of air. So that is an equivalent of 0.21 cubic meter of oxygen and 0.79 cubic meter of nitrogen. So you will notice, so bakit ito lang sir? So usually we have different gases, but we will be dealing these properties, will be using only nitrogen and oxygen. That is because they have the bigger percentage of quantity. So later on, we'll be discussing the quant. I will show you how much quantity, which is already, kung consider pa natin sila, it is mostly, tawag dito, not necessary to idagdag sa computation during the stoichiometric analysis. So we'll be dealing only, we'll be using in stoichiometric analysis is the nitrogen and oxygen. And other traces of inert gases will be hindi na gagamitin. Now, by means of gravimetric analysis, so we have your percentage of gravimetric analysis. We have 23.1% by mass basis for your oxygen. Then for nitrogen, we have that will be 100. So usually we assume this one is a 100, no? So that will be 100 minus 23.1. So we have 76.9% by mass basis of nitrogen that we have. So by percentage basis or gravimetric analysis. Now for volumetric or molar analysis, so we have for your oxygen, no? So we have here that is 21. So by means of percentage, we have 21% by volume of oxygen. Then for your nitrogen, we have 79% by volume of your nitrogen. So this is the two types of reporting analysis that we will be dealing later on.